Okay, we have a point here, and I've indicated that point. Let me just kind of redraw what I had to start with. That's not a very good vertical line. Okay, I just kind of did this. So here's a projection line back to the x-axis. Here's a projection line back to the y-axis. And here's a vertical projection of the point down into the xy plane. The coordinates here are x, y, z. So the coordinate here is x, the coordinate here is y. And if I sketch a line from the origin to this point, I can sketch a line parallel from this point to the z-axis, and I get the z-coordinate. Okay, and I didn't actually do that over here. I just labeled the length of this segment as the z-coordinate. So here's our z-coordinate, but that could be projected parallel to this vector back to the z-axis, and we'd see the z-coordinate on the z-axis. Okay. Okay, well that's very good, but now we want to talk about cylindrical and spherical coordinate systems, because there are so many things in three-dimensional space that have cylindrical and spherical symmetries. And when we're dealing with something that has a cylindrical or a spherical symmetry, or has something, has some aspect of cylindrical or spherical symmetry, it gets awkward and cumbersome to deal with that in x, y, z coordinates. It becomes much simpler to deal with it in the coordinate systems I'm going to introduce, one of the two coordinate systems. Now, the cylindrical coordinates of this same point are going to be as follows. We take the point where this we take the point where this point projects down into the xy plane, and we draw a vector from here to here, if you wish. And that vector is going to have some length r, and it's going to make some angle theta with the positive x-axis as we move in the counterclockwise direction. And you'll recognize these coordinates as the polar coordinates of this point in the plane. So, if we specify the polar coordinates of the point in the plane that are directly above or below the point that we're trying to label, then we have two of what we call the cylindrical coordinates. And the third cylindrical coordinate is just how far above or below the plane we are. And that coincides with the z-coordinate from our rectangular system. So basically we've taken the xy part of our rectangular coordinates that we understand pretty well and replaced that with the polar coordinates in the xy plane. And we've kept the z-coordinate the same. So if we know r and theta, as you know from understanding polar coordinates, that allows us to describe any point in the plane. And then all we got to do is say how far we got to go up or down from that point, and we get the coordinates of a point in three-dimensional space. The relationships between the x, y, and z coordinates and the r, theta, and z coordinates are just what you'd expect. We can see those relationships. We have the r vector here, and we have a projection back to the x-axis. We have a right angle here. So the x-coordinate is just the side of this right triangle adjacent to the hypotenuse, which has length r, or magnitude r. Follows then that this side is just r times the cosine of theta. And usually these videos are aimed at people who are very literate with right angle trigonometry, because most people who take this course here have had a statics course. But one way or the other, if you've had pre-calculus, you should be very literate with right triangles, trig. So it should be very obvious to you that this side is the length of this side times the cosine of this angle. And also that this side of this little triangle here is going to be r times the sine of theta. And that side, since this projection goes at a right angle, is going to be the same as the y coordinate, so that y equals r sine theta. So those are the relationships, and of course you have inverse relationships that I didn't mention here. If you know x and y and you want to find r and theta, well, it should be obvious to you that r is just the square root of x squared plus y squared, and theta is just the arctangent of the y coordinate divided by the x coordinate, where also you have to add 180 degrees or pi radians, and when we use these systems we use the default units of angle, the radian. Okay, so we would add pi to whatever angle we get here if the x coordinate happens to be negative. So that's very, it should be very familiar, that kind of transition. Now the spherical coordinate system will be just a little bit less familiar. So I'll do that in a separate video, and we'll talk a little bit about these relationships.